Welcome to my video on my ALU functions. There's 11 total. These are just the non-add and subtract ones, all the other functions. I'm just going to be going through them one by one. Currently, I have the truth tables of all the binary functions in register 7 and 6. 7 will be the A value, and both of them 0, 0 for the first thing, and then A is on, B is off, A is off, B is on, and then they're both on. And then the next 4 bits are the exact same thing. Pretty simple truth table for those that know how to read them. And then our answers are going to be stored over here in register number 8. So first function is XOR, pretty simple. Just going to run it. And then we can go head over and look at the answer. Alright, so just as expected, the A and B ones, which one of them is on, are on here. When they're both off, it's off, and when they're both on, it's off. Reading these, it's just this register up here. If this is on, then it's on. Don't read the torches. They deceive you. Since it's with instant wire, that has to be opposite. So that's why they're there, is to invert the stuff for the pistons. Alright, next function is XNOR. And it should be the exact opposite. Now, and here we are. It's exact opposite. When both are on, it's on, and when both are off, it's off, and when one of them is on, it's not on. Alright. Next function is, I believe, AND. So, pretty simple function. Just the, when it's both on, it's on. Both off doesn't count. Yeah, pretty simple. It's the easiest one to do with instant wire, because you just combine the two inputs together. I should probably adjust it. Next function is NAND. It's the exact opposite of AND. Alright. Let's see. Yeah, exact opposite. When they're both on, it's off, and then any other thing, it's on. The next function is, I believe, NOR. OR comes later. I skipped it. I'll explain later. Alright. NOR should be when anything's on, it's not on. So when both are off, it's on. Any other time, it's not. So here we go. Oops. I changed it. The next one is not implies. It's A does not imply B. It's just the opposite of A implies B. So for this one, it's kind of an odd one. When A is on, it's on because it's the opposite. Normal one, it would be on every time, but when A is on and B is not on, implies it's just kind of one of the weird ones. There's no B implies A in there. I removed it because it's kind of stupid, because you can just put B as A and A as B. It's a pretty easy switch to do. There doesn't need to be code for it. The next one is implies, just the standard A implies B, which, as you can see, is on all times except for A is on and B is not on. Pretty simple. Next function is not. But currently, if you can look up there, you can see the wires get less. That's because it ORs A and B up there. So it's going to give us the same result as NOR, but it's just if you want to send, you want to OR the two things in opposite them. It's kind of what NOR does, but if you just want to send one thing through or something like that, I might remove it because it seems kind of useless. Alright, it's pretty simple. It's just on when they're on, same like NOR. Alright, the next one is just OR, because the wires OR, so I just don't do anything. I just throw the wires straight through. Pretty simple again. and it shows up all around except for when it's off. Pretty simple. Alright, nearing the end here. This next one is a shift right, where they're all ORed. So you could send either A or B and then nothing with it. Doesn't really matter. But anyway, all these were on, so as you can see, these three would normally be on in an OR. They're all shifted to the right. Same here, shifted over the right. And the last function is a shift left. So just basically the exact opposite of that. And then 2 over here, because one got shifted off, just disappears. And then the 2 over here that you would normally see. Alright, and that's basically all the functions. So here, let me change this real quick. Right, just bring it back down just normal. What I have down here is a random number generator. Each one of these relies on just the random number in your computer deciding to update this torch, and it's just set with a long line here. So when it does eventually get a pulse, it holds a state. So when you look over here, generally there's about 4 lines on. I tried to make it about 4. There can be more. I've seen 0. I've seen 256 on. So it's relatively random. It's not perfectly random, and I can just quickly draw a number from it. Currently, only B is hooked up to the random number generator, so I have to use B to do it. And the number for it is 6 or 15, just all on. And storing number 8. Alright. Just going to pull a random number. Just 1111. Just do another. Oops, disoriented. Those 2. Surprised it's not getting the higher ones, but oh well. There we go. There's a higher up one. That's 2 down there. So it's a pseudo random number generator. There's no real random ones, but trying to make it as close as possible. It's kind of hard though. But that about concludes the video. I think that's all the functions and all the little details I have to show. It is just a stacked ALU. Currently some of the numbers are not in use, so I'm thinking of some ideas for those. Some of the functions, like B implies A, I took out, so I don't need those anymore. But they're pretty simple. They're not instant, but they're like 1 tick or something like that. They run on instant wire, so they had to be specially made. I don't think anybody's made gates a whole lot like them before. So, alright, that's it.